I would like you guys to actually copy down this title, Analyzing Graphs of Polynomial Functions. You could also jot down the section that this is. It's 5.4. 5.4 from the book. 5.4. Okay, so it kind of belongs together with the last section. We're still going to have to state the degree. We're still going to have, whether it's like odd or even. Okay, actually I forgot to put that. Let me write that in. Odd or even. Okay. State if A is positive or negative based on the end behavior. And then also you need to state the end behavior. And you need to estimate the real zeros. What are real zeros? The real zeros are simply what? Anybody? The answers, which are on a graph, the x-intercepts. Correct. Good job. And then we're going to throw in two more things. That's what's special about this section. They're going to talk about relative maxima and relative minima. And other books call it local max and local min. As opposed to, and I guess we could throw this in as number 7 here, which is absolute max and min. Okay, so relative max, relative min, absolute max, absolute min. It'll all make sense in a little while. So, just for kicks, let's start by looking at an XY plane here. And let's say I had this curve. Would you believe that that is an odd degree function or an even degree function? That is an odd degree function. Why is it odd degree? Because the end behavior, one end behavior is down here and the other one's up there. So it's odd. It's kind of like me asking you this. How many arrows are going up forever? How many arrows are going up forever? 1. That's an odd number. Boom. As opposed to, let me get rid of this. As opposed to, let's say I had this right here. How many arrows are pointing up forever? 2. So is that an odd degree function or an even degree function? It's even. See how easy that is? Cool? And in addition to that, we should also know if our A value or our leading coefficient is positive or negative. For example, if I have this graph, is that odd degree or even degree? It's even. Why? Because, well, there's 2 arrows going down, so that's even, right? So it's an even degree function. Is the A value positive or negative? Negative. If it were positive, the end behavior would be up here. It's negative, the end behavior is down here. So that is an even degree function with a negative A value. So we're going to have to do this on tomorrow's quiz. Make sure you know that. You're going to have to say whether it's odd or even, you just told me. And state if the A value is positive or negative. Right here it's negative. Okay, let's go for another one. Let's do this guy right here. That's pretty straightforward. Is that an odd degree function or an even degree function? That's odd because there's only 1 arrow up or 1 arrow down. It's an odd number. How about, is the A value positive or negative? See, in order to determine that, you need to remember what x cubed looks like, right? And x cubed does start off down here and goes up that way, right? So this is a positive A value. So is this odd degree or even degree? Odd degree. And what do you say about the A value? Is it positive or negative? It's negative, right? Because the positive odd degree function goes like this, but this one got where it has the end behavior over here, it got reflected, which means that the A value has to be negative. So we need to be good at this on tomorrow's quiz. Should we try another? Odd degree or even degree? Odd. Positive or negative A value? Negative A value. That's right. Because remember, the original cubic function goes like this. That's the original cubic function. Y equals x cubed. That blue one is y equals x cubed. Now, if you know that, well, if you threw a negative right in front of it, it would cause this to flip that way. So just remember the original, y equals x cubed, starts down here, goes up that way. So any odd function that starts down here and goes up this way is also a positive a value, or has a positive a value, but this one is opposite n behavior. So that's why this a value is negative. So let's keep looking at this red graph right here, and let's actually describe the n behavior. Okay? Describe the n behavior. So we're going to start with as x approaches what? And here's the x-axis. Which way do you want to look at it? To the left or to the right? Let's start with to the left. So as x approaches what? This way is negative infinity, right? Negative numbers, -1, -2, -3, -4, all the way to negative infinity if you keep going that way. So as x approaches negative infinity, then f of x approaches positive infinity. Sorry, it's ugly. But yeah, as you go this way, that red graph goes up, positive infinity. Okay, now let's look at the other direction. As x approaches positive infinity, f of x approaches negative infinity. As you look at it to the right, as x approaches positive infinity, 1, 2, 3, 4, 5, 6, that keeps going forever. Where's the graph go? It goes down forever on the y's. So that's n behavior. You're going to have to state those. You're going to have to do that on tomorrow's quiz also. And now, how about the real zeros? Well, it's kind of hard to do right here, especially because this was just a rough sketch. But an estimate of real zeros, well, you could say it looks like it crosses the x-axis right here at the origin. So 0 is an answer. Maybe 3 is an answer because it crosses the x at 3. Maybe -1 is an answer. Maybe -5. Maybe -7. Right? So those are all estimates on answers. Of course, if it were a perfect graph paper, you'd be able to count exactly where your answers are at by looking at the x-intercept values. Okay? And now let's move on to the new stuff. Relative max, relative min, which is local max, local min, compared to absolute max, absolute min. So this is from the book. This is page 330. And here's an example. And let's pretend that you don't see this, right? Let's pretend you don't see this. Let's just look at the graph right here. Actually, let me do this. Look, you don't see it. Is this an odd degree function or an even degree function? Even degree. Is the a value positive or negative? Negative. Because if it were positive, it would have the same n behavior as a parabola up here, right? So it's down here, the n behavior, so it's negative, yeah? So we just said that it's an even degree, and the a value is negative. And if we look at the equation over here, yeah, it's even degree, and the a value is negative. See, we already knew that, even without looking at the graph, or at the function. Now, what they do in the book, and what they would like you to do in the book, is to pretty much waste a lot of time. What do I mean by that? They want you to make an XY table and plug in some numbers into X, work it out with your calculator, get out an answer, and then graph it. We're not going to waste time doing that. We're just going to jump straight to the fun stuff, which is identifying everything that we can with regards to this graph. So, is there a maximum value? Is there a maximum value? Does it at any point reach a maximum height? Yes, right here. This is the maximum height. As a matter of fact, I would call it absolute. That's an absolute max value. There is no other value higher than 8 point something, right? Or maybe 7 or 9, I don't know. Now, when they say local max, now there is no local max right here, but let's pretend that this graph went up, and then it just made a slight dip right here, and then it went back up that way, okay? Now, this right here is what we would call a local max value, if it actually did that. I'm just using this diagram to talk about it. This is what we call a local max. Local max. Okay, so what's the difference between an absolute max and a local max? What's the difference? Local means just nearby. So if you look at this, just nearby, it looks like that's a maximum value. But if you consider the whole thing, it does go up more. So we know that this isn't a real absolute max value. It's just a local max value, or as the book calls it, a relative max value. But there is an absolute max value. That's the one that goes the very highest up there. Make sense? Now, on this blue graph that I drew, I modified it so you could actually see the local max. Is there an absolute minimum value on this graph? An absolute minimum value? There is no absolute minimum. Why? Because the absolute minimum is actually negative infinity. It keeps going forever down. So it doesn't have an absolute minimum. I guess you could say the absolute minimum is negative infinity. But there is a local minimum according to what I just drew. The local minimum will be right here. So think about it. It's going up, going up, going up, going up. Then all of a sudden it goes down, and then right here's a minimum value. That's what you call a local minimum value. Okay? So let me put this in green. This right here would be a local min. Local min. Or as the book calls it, relative min. Okay? So do we understand the difference between absolute min, absolute max, local min, local max? And this is also from the whoa, what's happening? It's going crazy. Sorry. This is also from the book right here. Let me bring it up. This is from the book, and like I said, they like to call it, they don't call it local, they call it relative. I like to call it local. So local max or local min is the same thing as relative max, relative min. So if we look at the example they give, they show the local min right here. Now, why isn't it the absolute minimum? Why is it not the absolute minimum? Because it still goes down forever to negative infinity. And this one's also the relative max. Why isn't it not the absolute max? Because it still goes up forever. So those are just vocabulary that we need to understand so we could be tested on tomorrow's quiz. Okay, guys, what do you think about this guy? Let me ask, even before we look at the function, tell me, is this an odd degree function or an even degree function? Odd degree, perfect. All right. Now, is the a value positive or negative? Positive. That's right. Okay, so we know that the leading coefficient is a positive number, and we know that this is probably a x to the third or x to the fifth. Let me just scroll over here so you can see the actual function. And yeah, it is an x to the third function, and it is positive, the a value, like you guys said. All right, so we have this function, and we're going to be using the graphing calculators next week, so you don't have to worry about making an XY table. You'll just be able to type it in. You'll be able to see the graph, and there's a bunch of other things you could also answer besides odd or even degree, besides the end behavior. End behavior. As x approaches negative infinity, where does f of x approach? Negative infinity. As x approaches positive infinity, f of x approaches positive infinity. All right. How about what is your, let's say, absolute max? Absolute max. If they ask you, what are you going to say? What's the absolute max? Positive infinity. Why? Because it goes up, it stops right here, but that's not the absolute max. It goes up forever. So what's the local max or the relative max? Yeah, 2.5. And you know what? Let's give a coordinate here because there might be more than one local max. All right? Like it might go like this, like up, and then keep going like that. So it actually has two local max. So it's a good idea to actually give the full coordinate when you're talking about the local max value. I would say the local max is about 0.5 on the x and maybe 1.6 on the y. I don't know. Right? 0.5 and then maybe 1.6. That's the local max. So we're going to have to answer all this stuff on tomorrow's quiz. Please make sure you complete all your homework and watch this video so you can be better prepared.